So this is the second part of the Lab 8 videos. So the first thing I'm going to do, look at my thing. There we go. Alright, so this is on the PIC 16F84A. And the first thing we're going to do, of course, is draw all our nice little oscillator pins. Now in this lab, we are going to be using the matrix keyboard, and if you get the one supplied with the PIC Trainer Board, you only get a 3x4, or there is 12 buttons, but there's only 7 pins, but there's 8 pins on this connector down here. So what we are going to do is we are going to align it so that way we only take the pins that are circled. There's 3, 4, 5, 6, 7. Alright, and that way, if you align it this way, then you can follow basically the same instructions that I'm doing. Alright, now in this lab we need to be able to scan. So we take the first 3 pins and we move them to port B. I'm going to color the column and the row wires different colors so that way it's easier to tell. Alright, so those would be the column, or this 1, 2, 3 columns. And then this other color that I'm going to put down is the rows, or the 1, 4, 7 stars. So there's that one. Let's go this way. It might be a little cleaner. And it's not going to be. Alright, so basically if you're following what I'm drawing, you're pretty good, because I just drew all over the place. But anyways, I think I drew too many pins. Yes, I did. So let's take out that last drawing. Alright, so there we go. There's 4 rows and 3 columns. So now you can write your code however you want. Just remember that you're scanning on 1, so you're moving that 1, 0 combinations around. And on the other, you're looking to see which reaction you get. Now the other part of this lab is that we are going to take the output, we're going to scan, we're going to get an output, and we're going to put these on the LEDs. So because we are going 0 through 9, that's 10 numbers, power, so we have 2 to the n, so therefore n is equal to 4 to meet 10. Alright, so let's take that out. We'll put it, so we'll put that over here, 2 to the n, therefore n is equal to 4 meets 10 digits. Whoa, what the heck's happening here? 10 digits TS. There we go. Alright. Now we will use port A, the first 4 pins. So here we go. Here's 1. It doesn't matter which order you really attach them to, just as long as you know which is your LSB, which is your MSB. When I did mine, the MSB was this very last line that I will be drawing, and the MSB was the very first one. So it's up to you really how you want to draw it. And that's how to do that. Now all you have to do is really write your code. The one other part that I really wanted to talk about was how to do your scanning exactly. So we all know that we can do scanning. We know that's the 1, 0 cycle, ring cycles. What you want to do is you want to hold the LEDs constant so you don't have these flickering. And you want to do the ring count and ring count. So to do that, we'll assume that we are rotating on B and outputting the LEDs on port B. Okay. because this just makes the logic a little bit easier. So we start off, and the upper 4 bits of B are the ring count, and the lower 4 bits are the LEDs. Okay. So now taking that into mind, let's change colors. There's pretty color. So to start out, we're going to initialize 0, 0, 0, 0, and 0, 0, 0, 0. So that turns everything off. Now for the first rotation, what we're going to do is we're going to have basically we'll put 0, 1, 1, 1 because we're rotating the zeros, and we'll keep the zeros here. Now let's say we get a number. So let's write this in the hex form 70. Alright, so let's say we get a number. We'll call it 5. So the next time we come around, we're going to put a 5 here, or 0, 1, 0, 1. And we'll put this in hex as 5. But say we want to move this around to be E, or 1, 1, 1, 0. So this is our first step. This is what we want second. So how are we going to approach that? Well, the first thing to do is to set the lower 4 bits. So to do that, you have to mask off the top. So we can say and port B with 0x 0f. Okay, that'll clear out. What does this look like? This is 0, 0, 0, 0 followed by whatever was there, so we'll put x's there to represent that. Whatever was in the lower 4 bits at the time. Now to make the upper 4 bits change to the next cycle from 7 to E hex, we can add port B and what number? 0xe0. And this will have the result of putting, actually that's not right, having a 1, 1, 1, 0, followed by what was ever there. And you can do this logic however you want. So as we're rotating our scanner, we're going to be following this kind of little algorithm. So that way we can keep the LEDs from flickering rapidly between 0 and whatever number it happened to be previous. It also happens to save some memory, which is kind of handy on this PIC. And it also allows us to do our ring count, because we just start adding in numbers. And that is all that we wanted to talk about today. So now you should have enough information to do your